So thank you, Korak, for the wonderful introduction. And hi, everyone. My name is Puneet Jindal, and I'm CEO at Labeler. So first of all, I would like to thank Analytics India magazine to give me the opportunity to be here on this stage, having a discussion. So I'll keep it simple. It's just a few set of videos that I'll be showing here, not too much details. So why computer vision? And so it's one of my passion to solve for wherever there are vision sensors. And why data? I'm sure the last couple of sessions were agents, agents, agents. And then you probably, the last session actually, a wonderful session by Akash, right? There was discussion about training data, right? So I have been in the past, so I've worked for 12 plus years building AI products, started my journey as software engineer, and moved to business intelligence, and then moved to machine learning, solving predictive problems, and then got into deep learning, handling image and video data. And these were the companies like Walmart, Delivery, RateGain, FSoft, Librate, spread across e-commerce, logistics, healthcare, right? One common pattern is where I found out that I can enable a lot many AI ML engineers teams if I focus on my focus on the building the data systems for them, so that they can focus on building the AI systems faster and faster time to the market, right? This is something like my personal feeling used to be, can I just iterate on my algorithm without worrying my data for tomorrow, right? So that's a focus. So whatever I will be sharing, it's a contribution from my team. So these are from my team members. We are quite a small team, 15, 20 member team. So yes. So one question that I would like to guess, it's just an interesting question. I haven't got the answer. Even ChatGPT also couldn't give me the answer, but I would like to estimate. How many number of vision sensors across the world? What do you think? Anyone would like to answer quickly? Human population, okay. So good direction. Anyone else? Anyone else? How many vision sensors? 3 billion. Sorry? Okay, cool. So just to quickly, move to the answer, right? There are CCTVs. You have your smartphones, right? Everywhere there is a camera. And then we are building robotics, and so many places, CCTV surveillance is going across the world, right? So the number is probably, in billions, but then the number is some double digit or even 3 digit, in my understanding, right? If we start counting and start guesstimating, and as Elon Musk said, right, every human would have one humanoid robot by 2040. So think about how many vision sensors will be deployed across the globe, right? So AI is going to be more smarter. It was started with machine learning, deep learning, we can say generative AI. Now we call agents, and probably 3-4 years from now, we'll be calling it as baby AGI, and then we'll be saying that everyone is going to do AGI, right? Of course, the benchmarks are getting bigger and bigger, but then, the point is that there is a lot of data that would be generated. So I just want to show some video, right? So how can I play this video here? Excuse me. Yeah, okay, got it. So if you look at this video, right, what's happening? You're just detecting some objects, right? This is one of the scenarios of trash, right, in this video. Now, okay, cool. So detecting trash, could seem to be a simple problem, like, okay, I'm sure you must have seen the training data sets on Kaggle or other platforms, right? But then the point is the number of categories in terms of how much trash and how much type of trash that we are generating is kind of increasing at enormous pace, right? And then let me show you another video. So now if you look at this, right, all these are very basic tasks. If you look at surveillance, right, security, and other aspects, someone, someone fall in the warehouse, and you want to detect it, and then so this is one of the companies building video AI agents, and then what they are doing is like they are breaking down this whole net outcome, which is like if someone falls, you need to identify those situations, right? You need to build safer workspaces, right? Or someone was kind of trying to enter a space which was a restricted workspace, and then a system has to detect that and then identify and alert that timely, right? So what are these like small tasks broke down into set of steps, but then these are the agents which are doing this. Now, this is again where you have these images or videos data, which is supporting the AI systems. And now this one, a video. Cool. So this is the example of where a lot of innovation is being done on the farming robot side, right? Farming robots in basically continuously 24/7 identifying, moving through the first challenge for this kind of robot is like, how can I move without damaging anything? That's autonomy, right? The second step is like, how can I ensure that this robot picks the right strawberry at the right time, at the right ripeness level, right? So all this, it needs to learn within their data sets, right? Again, it falls back to training data. And now this one, another video. Cool. So this is one of the videos what Toyota AI Research is working on, and many other AI labs. The future of humanoid robots, they need to first learn very basic things, just as basic as folding a T-shirt, iron the clothes, putting a spread on the pizza, or maybe cooking chapati, right? So there are enormous type of tasks that we do in our daily lives. And if we want to make humanoid robots a reality, we need to first generate these data sets. And then such type of data sets are not there in the public domain, is going to be one of the biggest challenges, right? Just one of the old tweets by Andre Karpathy. How many of you know about Andre Karpathy? I'm sure many of you. Right. So he just posted this engine, and what are the videos that I showed, right? It's not something that generating data is a unsolved problem. It's a solved problem. But then a company like Tesla, did already for the self-driving cars, but that's one of the first use cases, in my understanding, in mainstream, where we actually got to know the value of building an engine which can generate data very fast and enable the AI systems to adapt, right? And so if you look at this, the workflow is very basic, right? Let's say you have your first model out there. In today's time, we do have generative AI models, right? You can directly start with that, vision language models and all, which will first, let's say, identify where the self-driving car commanded that, okay, whether you are doing it right or not. Let's say it made a left intersection where it should have made a right intersection, right turn, right? And then identify an inaccuracy, and then you identify what are those so many mistakes that the autonomous car has made. Use that to only focus on improvising the data. Let's say some mistake, whatever the mistake has done, the humans need to support that, improve that, right? And then put that back into the training system and kind of improve the AI model, right? Now, this essentially, it's like, it's almost like, in the technical terminology, it's a data engine which has a combination of iterative data acquisition or identifying the relevant data where the effort should be built, right? And then, focus on retraining and then evaluation. Now, evaluation is what? How many of you are from software, have been writing softwares, right? So we used to write software unit tests, right? So what used to work in software development as unit tests is what in the data domain is called data unit test. Interesting. Do search it out on internet how Tesla built data unit test, and actually what we are now naming it, something popular called as evals in a way. We are building those basic ground truth or benchmarks, saying that, okay, this is what is true, this is how it should happen, this is where my current engine is, or my AI system is. It has to operate in these limits, right? So we are sort of giving it some objectives, outcomes, right? In the agents world, we are going to give them the outcomes. So this as AI is kind of iterating, right? We are giving it new names because of their improved abilities. At the same time, the fundamental challenge would still remain the same, that how do we collect the contextual data? It's just that we need to give it more context, whatever is not available in public. So training data is the food for AI, is what is the underlying principle here, right? Now, the thing is, it might take a day to reach 80% accuracy. I'm just using the numbers very loosely. It might take a week to reach 85% accuracy. It might take a month to just probably cross 88%. And it could take a quarter to just cross 91%. And it might take a year also to just cross probably 92, 93%. Interesting thing, generative AI has helped us, is that it has enabled us to reach some basic accuracy levels. But the point is, as we are deploying it across systems more and more, and it has enabled the adoption, right? If there were 100 companies or 1,000 companies before generative AI, now there are like 10,000, a lakh companies which started doing AI. Oh, everyone said, oh, wow, now it's much easier to kind of build AI. But the moment they started doing that, and they deployed it, and suddenly started generating revenues, and said, okay, now we have more customers, more scenarios, and suddenly you find out that, okay, you don't have that data to optimize on that, right? And now that will happen same for agents. More and more we deploy agents, the more there'll be, it'll be easy for probably billion companies, not billion companies, but then, so the million companies to kind of build agents, but then everyone, in a nutshell, will be doing an AI, right? But then who will bring that data to the system, right? And so that's where the scaling challenges are, right? How to ensure that you get only the good data, or and as Andrew said, right? It's not the time of big data, but you really need good data for your AI. I would say in the context of agents world, right? You really need much more deeper data. More than good data, you also need the deeper data, right? Now anymore, you don't want to just detect a person, but you also want to detect what the action that the system should take, right? So that data, I'm sure you will not find not even like 1,000 data sets out there, right? So, and one of the instances, and the videos that by the way, the videos that I showed are all the real use cases that we are working with our customers. These were all customer names that we are working with. So whenever we talk to them, the AI leadership, right, the biggest nightmare for them, as we are doing and tuning the AI faster and faster, we say that, okay, we will update our AI every day. The more risky it becomes. Why? Because if somehow you have a system which is not able to control that bad data going into your AI pipeline, I'm sure I don't need to ask like all those AI engineers here what could be the outcomes and what risk that would be, right? So I have been at that space in the past, so it's really scary. So AI data bad quality, garbage in data going into my AI systems is really, really a nightmare for them. And so it's important for a data engine to identify and flag where is the bad data. And that's where it's really important, right? So I'll just quickly move further. So there are 3 components on a high level, though there are so many components to build a right data engine. Now, I could be talking about only the vision sensors right now, but then these things are, in a nutshell, applicable to other modalities as well, okay? Optimal data curation, quality and formatting, high-speed labeling. So I'll show again what that means. Optimal data curation is like, what is the most diverse data? Even Akash pointed it out, right? How do you generate diverse data sets, right? Diversity, right? It's not about the volume just, but then it's also about the diversity in the data. So you should have methods, you should have techniques to identify the valuable data for the right relevant use case. You cannot just go on identifying or using any data because there is a cost associated to it. You have to also bring it down. And then quality and formatting, as I already discussed, right? You need to have systems in place where you are able to identify those bad data points, right? It might be that you might not be accurate about it, but you have to be methodological. Instead of looking at all the data, you just look at the only few specifics, right? And then high-speed labeling is like humans cannot do scale up at large volume, so they need to focus on only the more of focus on the automation. So this this is an example of how you. So for example, you are probably building a robot which needs to walk through the campus, or let's say on the side roads, right? And if you're training for this, you are collecting some data, but then you need to have some systems that how do you collect and only use which is very, very relevant, and rather not spend your compute or your time or your energy on collecting the duplicate data, right? So there are some algorithms. Just an example. So in a way, in traditional sense, it's sampling, right? Sorry, just a video, if you can play. So this is an example of auto labeling. So now, this kind of task used to take, say, maybe half an hour, 1 hour, right? There are tasks that we do where it takes like 6 hours per image. For example, in food grain quality analysis, right? You have to literally identify shapes of, say, around 1,000 grains in that image, right? So how do you do that? How do you identify different type of grain and all, right? So traditionally, it has been manual tasks. And for an ML engineer, right, if you're asked to think that, okay, you have to build a model, and for that, you have to kind of need 10,000 data sets, and the other option that they're given, you really need to have 1 lakh data set, let's say, just images annotated with millions of annotations, right? I'm sure AI engineer would always choose a more data, right, direction. And so then such kind of automated labeling is needed to kind of, so that they are able to focus on training the AI systems rather than getting the data. Another is example of this autonomous movement in the survey, for example, of a survey vessel, which is kind of moving. Can you play the video, please? So if you look at this, so UX has a lot of role to play. I'm sure everyone knows, right? Our human brain understands images faster than some sort of text, right? 6,000 times faster, something around that, right? So there are ways then how you would innovate in your data engine, that you are able to kind of quickly skim through the data, the most important relevant data, which can help you identify and flag, right? One, an AI system can actually help you flag, but then still a human expert can do it even better way, as long as that AI-assisted system can actually help them where to look at, which 1% to look at, not just randomly guessing what data, right? And some sort of progress, and it's again, for an AI leader or even larger teams, it's always a question, how fast I'm moving, how fast I can get the data, and so on and so forth, right? So those, and overall project management, these are some important components of a data engine. Yeah, so happy to connect on LinkedIn. And so one thing, whenever I'm, so just wanted to share this, it always works for me. You start with whenever in doubt, right? You start looking at the problem, right? In today's time, there are a lot of tech noise out there. There is some interesting things are happening, but at the same time, there is too much noise in terms of how things are going to shape up. Every day, there is a lot of change. But then, fundamentally, if you look at things, if you look at a problem, when your customer is talking, you just focus on what is the customer experience that they are going to look at, right? What is the customer experience that they're expecting? And you build on that in such a way that, what technology can it solve, right? What technology can solve that problem is what I use that paradigm, and it worked for me. Yeah, thank you.